Lesson 5.4, Solving Proportions. We're going to have a theme of Bainbridge Island on this one, and you'll see why at the end. So you'll see the picture of the ferry in Bainbridge Island, but hopefully that just warms your heart just a little bit. Okay, so first we'll start with a definition. What the heck is a proportion? Well, a proportion is an equation, very important word, stating that two ratios are equal to one another. Let's try this. Oh, yeah, I like that. An equation stating that two ratios are equal to one another. Now remember that an equation is something that has an equal sign and something on either side. And usually we solve an equation. In this case, I've given you one that you can't solve, but in the next page, I'll show you ones that you can solve. So it's an equation, we got that, check, stating that two ratios, here's one ratio, here's another ratio, are equal to one another. Ratios are just like fractions. So it does look like fractions and they work the same way. So look at this. 5 times 2 is 10. 8 times 2 is 16. Isn't that nice? Okay, so that's what a proportion is. Okay, if I want to look at something, 5 and 16, those are my smallest number out of the 4 and my largest number out of the 4. They call that the extreme numbers. Extremely small, extremely large. If I look at 8 and 10, those are my middle numbers. They actually call that the means because mean is referring to average, which is the center numbers or the middle numbers. So when I multiply my means, 8 times 10, I get 80. And when I multiply 5 times 16, well, I'm not really sure what that is. So do that over here just to check your work. And you get 80 again. So notice the cross product. Cross product is the means and the extremes. When you multiply them, they're equal. Well, let's see if it's a fluke. If I have 2/3, okay, and I'm making another ratio or another fraction that's equal to 2/3, let's multiply it by 4. So times 4 would give me 8. Times 4 would give me 12. Okay, I know these two fractions are equal. Now let's look at their cross product. So I take my smallest and largest number, which is 2 and 12, which thankfully will always be diagonal from each other, and I take my middle numbers, 3 and 8, and I'm going to multiply them. What's 3 times 8? Oh, 24. What's 2 times 12? Oh, 24. Look at that. The cross product is equal. And you will see that it is always going to be equal, assuming that the two are set equal to each other from the beginning. So why is this important? Well, a lot of times, see the frog rock and the ladybug, so cute. A lot of times you're going to get a fraction that has one unknown in it. So we have a k here and we got to figure out what it is. Well, in this case, you would have been able to solve this question last year in elementary school because you would have said, oh, I already know because 5/15 is the same as 1/3 because I just take 15 and I divide by 5 and I take 5 and I divide by 5. Okay, and 15 divided by 5 gives me 3, 5 divided by 5 gives me 1, so k equals 1. Right? Right. Okay, so that's probably how I would do this problem, but I'm going to show you how it would work if you used the cross product. Okay, because that's going to be incredibly helpful. I'm going to keep my answer here so I can see it. So if I use the cross product, I'm going to say, all right, I've got 5 and 3, which are going to be my middle numbers. 15 and k are going to be my extremes. And I know that because 15 is the largest, so k will, because of the positioning, be the smallest. Okay. So 3 times 5 gives me 15. That's this one. And it's going to equal k times 15. Okay, so I have 15 on this side and I have k times 15 on this side. In order to get k by itself, I want to do the inverse operation for multiplication, which is division. Divide by 15, divide by 15. That cancels, and I get k equals 15 divided by 15, which also cancels, but leaves me with a factor of 1. I get the same answer. I do think you should do it the fastest way possible, so I think that the original method in this case would work. But if you look at my problem here, you'll see 7 to 10 is not as nice as 3 and 15 was. So if I jump right to my cross product, which the book will do with you, and this one, I'm going to circle it to remind me, and then I'm going to say, okay, 4 times 10 equals 7 times f. 4 times 10 gives me 40. 7 times f gives me 7f. Well, now how am I going to figure out what f is? Well, I have multiplication here, so I'm going to use the inverse operation, which is division. Divide by 7, divide by 7, and I get f equals 40 divided by 7. Well, if you have a calculator handy, do that. But if you don't, you can use a mixed number. 7 goes into 40 how many times? Oh, 5 times with 5 left over. So f equals 5 and 5/7. So this f right here equals 5 and 5/7. In order to equal 4/7, it would be 5 and 5/7 over 10. Okay, great. Now, when is this used in real life? Guess what? A lot. Proportions actually are used a lot, whether you're actually writing them as proportions or not. Here's a situation, by the way, point white dock. I wish I were running down here and jumping off right now, except for that it's freezing. And Blackbird Bakery, because we're talking about cookies. Okay, so we're talking about if 6 chocolate chip cookies have 18 chips. I'm actually going to use my fun highlighter. 6 chocolate chip cookies have 18 chips, then how many chips are there in 21 cookies? Okay, so I'm talking about 2 different things here, chips and cookies. So I need to make a little key for myself. I'm going to tell myself I need to do cookies on the top and chips on the bottom. Okay, you could have done chips on the top, cookies on the bottom. It actually doesn't matter. They can both work either way. Okay, so then I start by saying, all right, I'm going to make a proportion. So a proportion looks like this. Let's fill in the blanks. I've got 6 chocolate chip cookies. So 6 cookies goes on the top. Have 18 chips. 18 chips is going to go with chips on the bottom. How many chips? Okay, chips is X. Are in 21 cookies. 21. So now I've got a proportion, and I want to go ahead and solve it. I can cross multiply, which would give me 6x equals 18 times 21. I didn't write that right. 18 times 21. Well, I don't know 18 times 21. There actually is a faster way here. I don't know if anyone can see it, but I get 378. So 6x equals 378. Divide by 6, divide by 6. And because I did this problem already once, I know this division problem gives me 63. Well, what the heck did I get here? So go back to your problem and say, okay, x was here, that's going to be 63. And trace it back to my words. Oh, okay, 63 chips. So now I can label my answer properly. Okay, the faster way, had you done it this way, it would have just lined up as 18 over 6 equals x over 21, because 18 is chips, x is chips, 6 is cookies, 21 is cookies. And you would gotten the same answer. The shortcut here would have been to reduce this before proceeding with cross multiplying. If I reduced that before I cross multiplied, I would have saw that 6 goes into both of these numbers, and I would have had 3 over 1 equals x over 21. In which case I could have done it the old way, or I could have done it the cross multiply way. 1 times x equals 3 times 21. Well, 1x is just x. 3 times 21 is 63. So another faster way to get it. Lots of ways with these proportions. I think they're actually kind of fun. Okay, last item. If you're looking at a map, this is another time you would use proportions. If you're looking at a map, you're going to see a scale drawing. So here's a map of Bainbridge. Try to find your house. This one doesn't come with a scale. I made the scale up. But a lot of times on a map, you're going to see a scale. 1 inch to 2.4 miles. That just happens to be the scale that I used. You're going to see this in the book. Linus's lair is the one that he refers to. It's a picture of his room, and he makes a map of it, and he has a scale. Because obviously I can't draw the exact size of Bainbridge Island on a piece of paper. It would be a very big piece of paper. Okay, so 1 inch is referring to the map because I'm measuring the map in inches. 2.4 miles is talking about the actual distance. So 1 inch, which might look something like that on the map, looks like that would be 2.4 miles in real life. Okay, So let's see if we can go ahead and do the math on this. I'm just telling you that I measured this length, okay? The length from the top of the island to the bottom of the island. And of course it's approximate. And I got 5 inches. But I had to use a ruler for that. And on Linus's layer, you're going to have to use a ruler. The width from here to here was 1.6 inches. So that's the actual measurement of the island using a ruler. Okay, well, how do I find the actual distance in real life? Okay, well, so I do the same thing as I did before. I did map to actual, and you could do this the other way around, but I'm going to do map on top. And I start with what's given up here, 1 inch to 2.4 miles. Okay, and now I take the information that I have, which is just the length. I have to do 2 separate problems here. The first is the length problem. The second is the width problem. Okay, so 5 inches. Where's that going to go? Is that going to go on map or is that going to go on actual? It's going to go on map. And what am I going to do with actual? I'm going to say that's x because that's the part I'm trying to figure out. Okay, cross multiply. 5 times 2.4 equals 1 times x. Well, 5 times 2.4, let's do the math over here. 20, 10, 11, 12, move the decimal, I get 12. So I get x equals 12. Well, what does that mean in real life? Go back. X was referring to mi, which is miles, which is the actual distance. So the actual length of the island is about 12 miles. Okay, well, what about the width? Okay, I do the same thing. I do map over actual. I start with 1 inch over 2.4 miles. And then I put in the information that I was given that I found using my ruler, 1.6. Does that go on the top or on the bottom? On the top. 1.6 inches over x. Cross multiply, I get 1x equals 1.6 times 2.4. And yes, I used an x because the dots were too much. Okay, using a calculator would ease the tension here or the time. 24, 12, 13, 14, 0, 4, 2, 3.84, move the decimal 2 over, and you get x equals 3.84. What does that mean? Miles, actual. So in actuality, the island across, the width of the island is 3.84 miles. So roughly 12 in length and 3.84 in width. Pretty cool, huh? All right, well, good luck with Linus's layer. I know this was another long video, but a very important topic that we will practice over and over again this year. Have a good day.